All right, in this very last section, we don't have like a ton of notes to take, but we've got to understand these different words. So first of all, we've talked about this briefly, but the word postulate, that's just like a rule. So a postulate is a rule that's been accepted as fact. A theorem is also a rule, but it's a theorem has been proven. So it's like a rule that has been proven or can be proven. So I'm going to say has been / can be proven. And the other word that we're going to see a bunch is converse. So all of these theorems, except for the vertical angles theorem, all of these are written as like an if-then statement. So for example, let's just pick one to look at. Let's look at the corresponding angles postulate. So in the corresponding angles postulate, it says if two parallel lines are intersected by a transversal, and then it says then corresponding angles are congruent. So this statement is written in the form of if, I'm going to call all this stuff P, then I'm going to call all this stuff Q. If P, then Q. This is what we call a conditional statement. It's a conditional statement, and in this case, P is what we call the hypothesis. Not quite what it means in science. And then Q is what we call the conclusion. And when we read a conditional statement, if the hypothesis is true, then the conclusion must be true. So if two parallel lines are intersected by a transversal, then the thing that must be true is that corresponding angles are congruent. So when we see this word, the converse switches the P and the Q. So for the converse, it's going to be written if Q, then P, meaning that Q is the thing we know is true. So if Q is true, that implies that P must also be true. So it just switches the hypothesis and the conclusion. So now, if we have two lines that are intersected by a transversal and the corresponding angles formed are congruent, then it must be the case that those lines are parallel. So I know it's worded a little different, but the top part, that was my Q. The bottom part about them being parallel is now my P. All right, so all of these theorems just go into detail what we talked about in the last section, that when we have parallel lines, that we're going to have, in fact, we could do like a quick little tree map out to the side. If we have parallel lines and these angle pair relationships are formed, there's a bunch of congruent angles. That's going to be our corresponding, our alternate interior, our alternate exterior, and our vertical, and those are always congruent. And then we have these supplementary angles. That's going to be like our same side interior, our same side exterior, and our linear pairs, which are always supplementary. So the important thing about the converse is it tells us that if I have if I have alternate interior angles that are congruent, then I can prove that the lines are congruent. So kind of a summary at the end, if you read it from left to right, you're reading the theorem. So from left to right is each theorem. So for example, I would read if two lines intersected by a transversal are parallel, then I'm going to pick one, then same side interior angles are supplementary. However, if you read it from right to left, you're reading the converse. So if same side exterior angles are supplementary, then it must be true that the two angles intersected by the transversal are parallel. I know the wording changes just a little bit, But that's this is going to be really helpful when we're trying to prove something. So when I'm trying to, for example, prove that angles are congruent or supplementary or that lines are parallel. All right, that's really all we have for this last section.